I did not expect these to turn out this good. In this video, we'll be cutting out these 19 custom bottle openers. I'll be giving you some quick design tips, showing you a double-sided machining trick that made this whole project come together. And at the end of the video, we'll be breaking down if something like this is actually profitable to make and sell. Let's get right into it. So I got the inspiration to make all of these beer bottle openers from a previous video we did on the channel where we made a whole bunch of different bar products. And we made one of these beer bottle openers right here. And this project just got stuck in my head for months and I could not really get it out. And so over the course of the last 4 months, I started just kind of piecing together this hodgepodge of bottle openers right here. And the interesting thing is I wanted to still use the BamX material to get that dual layer look, and we'll talk about that a little bit more in the video. So believe it or not, all of these bottle openers right here fit on one single 2 foot by 2 foot sheet. We have to use double-sided machining, and there's little pocketing techniques that I've never really had to do because I've never made really small projects like this. So let's dive into how I designed these, how we're gonna cut these out today, and as we're cutting it out, I'll give you all the tips and tricks I learned along the way. Let's go. So the first thing we're gonna do and we're gonna cut out today is the back side of these bottle openers with that little inset pocket for that. And so we're gonna get this held down and I'll start talking about that double-sided machining trick because double-sided machining is kind of scary, but honestly guys, it is really, really simple. The best way to do this and the way we're gonna be doing it today is we're gonna mark a center origin on here, and then we're actually gonna have the CNC drill 2 pilot holes or dowel holes or pins, however you wanna name it, and they're gonna be at a certain distance away from the center origin, perfectly in line, so perfectly symmetrical. So as I mark this origin, I'm purposely gonna go at 11 7/8 and then 12 inches up, just so the origin is just a little bit off to prove to you that this pin method works good even if you don't have an exact center. So here's the file, and I'm drilling the 2 holes where the bit's not gonna hit them, and once again, they're exactly the same distance from this center outwards right here. So the bit I'm gonna be using to poke all these holes is going to be an 1/8 inch upcut bit. The reason I'm doing that is because my pins are just gonna be some simple 1¼ inch exterior screws. So I'm just gonna have this 1/8 inch bit mark these holes for me, and then I'm just gonna drill right in it. Let's drill some holes. A couple tips here as you get your project set up is that once you mark that X and Y origin, do not change it for the remainder of the project. There's never a need to reset it, just ever. Don't touch it, don't do it. Now as you notice, I'm just putting these screws in that the holes marked, or that the CNC marked, and then I don't even have to leave them in. All I wanted it to do was to make a mark in my spoil board so I can come back to it once I flip this sheet over and put those exact same screws back in, and those exact same holes will be there. All right, so I don't even need these screws in here, so I'm just gonna take them out because they're just for marking that hole. So the bit I'll be using for the pocketing today is this 1/4 inch downcut bit. I'm just gonna keep it simple, put a 1/4 inch downcut finisher in there and do these pockets. Nothing special. So the thingamajig slash doohickey thing that I'm using for the bottle opener is just this really cheap set of bottle openers off of Amazon. They're like $6-7, you get 20 of them, so I'll leave a link in the description for that. But whenever I did these holes, I made them universal, and so you can either turn it this way or this way inside the hole, and I didn't do them flush with this. The reason I didn't do them flush, and this is just me after cutting stuff for a long time, I don't like flush because flush means you have to be perfect. And if you have to be perfect, there's only one man that has ever been perfect, right? So I think this is like 0.7 inches thick, something like that. So my pocket for this rim is actually 0.15 inches thick, which is the exact thickness of this top layer of this BamX. That's why some of them pocketed out all the way, some of them didn't. Now the last thing I'm gonna do is I'm gonna put this 1/16 of an inch upcut in there, and it's gonna drill all of my holes for me. And now it's time for the flip. And what's so cool about this is since we already have these holes marked, right? Whether it's a screw, whether it's a dowel, whether it's a pin, whatever suits your fancy. Now I can just flip it, right? All right, so putting my screw in, and I'm just going to, fits right in that hole. Fits right back into that hole, and that's it. That's the whole double-sided machining trick. That's all you have to do. Now I'm just gonna put clamps back on these corners, and this piece is in the exact same spot we left it relative to the center origin, right? So now we're on to the pocketing part. We just flipped our material. We made sure it's lined up. And if you're like me, you have those little nerves inside of you that say like, well, what if this doesn't line up? What if this doesn't work? Trust me, trust the pin system, trust the CNC. This stuff is gonna work. It is much, much easier than you think. Now this pocketing right here is a little bit tricky. So whenever you're pocketing something like this, it's not as simple as just creating this vector and pocketing it out. There's a little bit of overhang you have to do, whether it's this guitar, this drumstick right here, the hammer, the football. All of these have a little bit of extra programming that has to come into consideration because it is an open-ended pocket and you're gonna be cutting on the outside of it. It's not like a closed off pocket like that. So let's hop on over to the computer and let me show you how that's done. So we just cut out these insert sections of the bottle openers, and there's a quick line for reference of what it's gonna look like when it's fully cut out. Now the file we're gonna be working off of today is the exact same digital file that you will get if you do decide to purchase this. I have a step-by-step guide here, and it's also going to be available on VCarve Pro, Aspire, and Carbide Create. So lots of different options for you guys here. Now, all we're going to do, and all this file technically is you just take this and you flip it, and you're going to get the other side of this file. So all you have to do is center it in the work section right here, and we're going to run our pocketing toolpath. Now, with these pockets, there is a little trick that I have done to all of these pockets that are open-ended that will help get a lot cleaner cut. So right here, this is the size of a 1/4 inch bit that we're gonna be pocketing with. Now, a lot of times you would think just to pocket out this area right here, but you always wanna do an overhang. That way, when the bit is pocketing, it can fully take out everything, because if you did not, it would stop right there and you'd have a little nip of wood that is left. And the same thing with, like, let's say this duck beak right here. So I oversized the pocket. It's a separate vector, as you can see right here, because I had to oversize it, because whenever this 1/4 inch bit is coming in here, if it were to stop right there, you would have a little nib of wood. And so you have to go past it in order to make sure that all of the wood gets machined out. And also, whenever you cut out this duck and have a profile, if the pocket is exactly on the line, there is a strong chance you're gonna get a tiny wall of wood right here along this line because the pocket stopped, and you're gonna have a little piece of wood that sticks up there, and possibly along this whole outer edge of this pocket, you'll have a little piece of wood because that's just the way CNCs are. So is there a better way of doing this? Well, technically there is a double-sided feature inside of the Vectric software that you can see and machine both sides and see what it's going to look like. But for most of you, the best option is just doing this flip method right here and just lining it back up on top of the job surface, and that's going to yield the exact same results. So we're gonna pop this 1/4" down cut back in to do all of this pocketing. Now, to make sure we break through that first layer of this BamX, we're going to go down 0.16 inches, and that is going to make sure that we clear that first layer, which is 0.15 inches thick. All right, getting a little nervous, but let's press go. So if you like what you're seeing so far in the video, don't forget to like and subscribe. And if you want anything in this video, whether it's the bit, the material, or the digital files, check out CIC Workshop. I'd love to have you. All right, we got everything pocketed out, and we are using the alt mill today, so if you want to learn more about the machine or want to get one, check out the link in the description. It does help out the channel. So one thing to note when all of this stuff is pocketing, like I was saying earlier on the programming side, is we kind of oversized everything. So if you look at this mallet, right, this pocket right here is oversized, so whenever the mallet sits on it, it may look a little bit bigger, but remember, we got to get those tiny little edges right there of this that 1/4" bit may not be able to get to, so we have to overhang that just a little bit to make sure that 1/4" bit can fully get it. So that's why some of these pockets are oversized, but when we cut everything out, it's going to be beautiful. So now let's talk about the cutting. Well, we're gonna be still just using that 1/4" down cut finisher that we've been using. All right, so our 1/4" down cut just did its thing. Now, what's so cool about leaving that thin onion skin, and you can kind of see it right here by this paw print, is that it gives you a chance to reassess, see what went well, see what didn't go well. And so one of the things that I'm gonna do as I'm cutting this out is I think these are gonna fly whenever I fully cut them out. And so I'm gonna go in, I'm gonna break out all these little pieces of this brass knuckle right here. That way these pieces don't fly out and poke me in the eye, right? And then right over here on this saw, I'm gonna break out this piece as well. That way these pieces just don't go flying. Now another thing that you can do, you don't have to do, you could use double-sided tape to hold all these down. I'm just gonna use some 3D tabs to make sure that all of these are held down. But I'm also gonna go in and see if there's this spot moves just a little bit. You can't really tell on camera, but I'm gonna put a screw in here because I know that this bit is not gonna hit it in any way, shape, or form because I already did that exact same profile. So I'm gonna go put a screw in right here, maybe right there, maybe over there, just to really hold everything down to make sure those tabs hold everything in place and none of these parts move before that final profile. Now, after we cut all these out, we'll talk about profits. All right, we're about to take that 1/4 inch downcut bit in one pass, cut out the rest of that onion skin and leave tabs. That way all these pieces get held in place. This is where I get a little nervous because, you know, things could go wrong, but I trust my CNC, I trust my instincts, so let's click go and run it. Sweet! This thing is looking beautiful. Even though I already cut this stuff out, it still gets me excited. Like, second time, baby. Like, let's go. It's looking good. But here's the moment of truth, right? So let's see. Let's pick it up. The tabs are holding nicely. We cut all the way through. And if you look, boom, that wrench, it's a perfect circle around that wrench. That means the flip went perfect, baby. And our tabs held good. We didn't cut too far through it. So now all I have to do is cut those tabs out, sand, oil everything, all of that good stuff. So let's go do that. So after I got these sanded down, I just put a mineral oil finish on them, but you can definitely put like an Osma coat or Rubio coat or just a nice clear coat on them, whatever you want. I just wanted it simple and easy. Now, you may be looking at all these and being like, oh my gosh, like that's so many different designs. How'd you come up with all that? Well, one, it was like 4 months of pondering all this, but what really helped me is when I started picking themes and then building these around these themes. So as we start talking about pricing, you know, I tried to make this a very wide variety to appeal to a lot of people. Now, obviously, when you cut all these, you may not be cutting all of them out just like I did. You may pick 1 or 2 or 5 or something like that, but here's how I designed these. So right here, I wanted something to work for like a lake house or a bay house, and so I got a little rubber duck, the fish, and the anchor. And then I thought like men, right? Like what do men want? Well, they want oversized chicken legs with a beer, right? They like football and they like trucks, like, yeah, trucks, right? And so I did that. And then I have the musicians. And so this is where the guitars came up. Got electric guitar, acoustic guitar, really cool there. And then I was like, okay, did one for the men. Now I need to think of something for women. So I was like flowers, random melting popsicle, because I saw it somewhere and somebody sent it to me. It was like, hey, this is super cool. And then a paw print. And so that's where you get the tulip, the paw print, and the melting popsicle stick. And then I was like, well, let's hit the gamers up a little bit. Maybe the fantasy football leaguers, right? And so that's where you get the Xbox controllers, possibly for the man cave, with the bottle opener in the back, the skull. And so believe it or not, the skull is my dad's favorite. Let me know what your favorite is in the comments, and if you would make any changes to my designs, because this did take me a long time. The next one we have is the World's Best Drinking Buddy Award, which is, I don't know, pretty funny to me. And we have my beer bottle opener, my official beer bottle opener. And then lastly, I wanted to do some different tools. And so we have a wooden mallet, not a hammer, a mallet. We have the good old-fashioned wrench. We have the saw, and then we have our CNC protection device right here. So if anybody touches your CNC, you do whatever you need to do to them and open you up a drink. So all of these are for the shop. Now I'm pretty excited about this little saw right here because I'm gonna give it to my son Waylon, and when he gets old enough, he can crack me open a beer, right? So pretty cool, and that's why I did it in mineral oil, so he can gnaw on that thing and have some fun with it. Because BamX is food safe, which is pretty cool. So now let's talk about pricing and are these profitable? Well, I cut out, and you just saw it, all 19 of these out of one 2-foot by 2-foot sheet of BamX. And all of those bottle openers on the back cost me about $6. So all in, you're gonna be under $60 for all of these parts right here. Now, cutting out on the CNC took me right about 40 minutes, but for you it may take longer because, you know, maybe you're not running it as fast. So let's say you have 2 hours of time put into it. So right now we have 19 beer bottle openers, or bottle openers. You have 2 hours on your CNC and about $60 in materials total. So 2 hours on the CNC, 50 cents a minute. You're looking at $60 for CNC time, $60 for material. So all in, you're in at $120. So personally, I don't know if you would cut out all of these and bring them to a show or something like that, but I would safely assume you can get 10 bucks a piece for them, like pretty handily, maybe even 15 bucks a piece. So if we assume on the low end, you can get 10 bucks a piece for these, you would be getting $190 from that sheet, which would leave you about $70 of profit on top of your machine time. Obviously, I didn't factor in your labor, but all of these took me about 30 minutes to sand. So not a lot of time there. So do I think something like this could be profitable? Absolutely yes. It just depends what you make, right? You can fit a whole bunch of guitars on a sheet. You can fit even more skulls. It just kind of depends, you know, whatever suits your fancy. So are these profitable? Absolutely yes. Are they fun to make? Yes. And do they kind of test your CNC skills? I would give that another yes. So I hope you left this video with more knowledge than when you started. And as always, guys, remember, if you ain't cutting it close, you ain't cutting it right.